We're going to be talking about the curve of best fit, and we're going to be using the calculator to do so. You guys are actually really lucky because when I was in school, we didn't have graphing calculators, and it was a really long, tedious process to find the line or the curve of best fit. You guys have some experience with the curve of best fit because last year you took scatter plots, right? And you kind of drew a line in there. Okay, and you said this is like the line of best fit, and you said does it have a positive correlation, a negative correlation, or no correlation at all, right? Depending on how the line sloped. If it sloped up, then, or had a positive slope, it had a positive correlation. If they were scattered all over the place, there was none. And then if it sloped down, then it was negative. So please stay with me. Don't try to follow the directions so that it's easier. All right, so the nice thing about the curve of best fit is it can help us make predictions with stat. People have large amounts of data and they can input it into a computer. The computer finds the line of best fit or the curve of best fit, and it helps them decide how much money to spend on fabric if they're a designer store. It just lots of different ways to use this. So first example, and this is on your notes, but just kind of follow along with me, please. So we've got the vertical drops of 9 roller coasters in the U.S. Pretty timely, because aren't you guys going to King's Dominion here with music shortly? All right. And it states in the number of years after 1988 that they were opened. And so we want to talk about the independent and dependent variables, look to see if there's a relationship, and predict the vertical drop in a roller coaster. And we can do most of that on the calculator. But you guys need to know what the independent and the dependent variable is. So who can tell me what the independent variable is? Is it years since 1988, or is it the vertical drop? Think about science. It's the thing that you control, kind of. So would it be the year, or would it be the vertical drop? What, Bella? You're not supposed to be anywhere on the calculator right now. Take the quiz. All right, you'll get this tomorrow. Yep, independent is usually things like year, time, maybe amount of water, but it's those kind of things. So our independent is the years, our dependent is the vertical drop. So the other thing is, when we're dealing with years, a lot of time we assign them values, because if you put in 1988, 1989, so on and so forth, it makes the equations really hard and it makes the data wear off. So we've assigned 1989 as the year since 1988. So this is I was writing this before. So this would be 1989. Okay. And then this here would be, we would add 15 to 1988, and we would get 2003. All right. Now, we're going to use the calculator to help us make some decisions. So turn on your calculators if you have not already. You should be at the main menu. Okay. And we're going to go to stat. So arrow up to stat and enter, or arrow over. You may or may not have data in your list. So we're going to get rid of the data. Does everybody have this menu, graph, calc, all that? So we don't have delete here, but we can remember from previous stuff that arrow means more, right? So we're going to press F6. And then which one do you think we're going to do? DLA, delete all, so F4. So if you press F4, yes, I want to get rid of it. Arrow over to the second list, delete all. Yes, I want to get rid of it. Okay. So we're going to recreate that table of roller coasters in this graphing calculator. So in list 1, we're going to put our years. So you just type in the number and then enter, and it puts it up in the list. So go ahead and type in that list. Don't forget to press enter. And notice I made a mistake. I can just scroll over it and type over. There are 3 12s, so you have to make sure to put in all 3 12s because it's different pieces of data. All right, and now in list 2, let's go ahead and put the vertical drop in feet. So you're going to arrow over, use the cursor, that big gray button, use the cursor and press over, and just enter your data. Don't forget to press enter. So 151, and you need to make sure that you do it in order so that the ordered pairs match up. And you've got 2 225s, so make sure you enter those. All right, so now what we're going to do is we want to look at a graph to make sure to look at the data. So I'm going to press more because I don't have anything that I can use, so F6, and we want to go to graph. We want to tell the calculator, everyone here? We want to tell the calculator what kind of graph we want, so we're going to hit set, which is F6. And it already should be in this setup. If it's not, you just arrow down and you could highlight scatter, and you can do all kinds of different graphs. We want scatter, but you can see we can do a histogram, a box and whisker, all kinds of different graphs, log, exponents, powers, cosine. But what we want is a scatter plot. And then in list 1 and list 2, we have our X list, which would be our years in list 1, and we have our vertical, which is our list 2, our Y values. Does that make sense? Everyone have that? All right. So I'm going to press more. Actually, I'm going to press exit. So remember, exit, it takes you back. And just a word on the exit. If there's stuff, like, and you're stuck on the calculator, like sometimes you say I'm stuck, on the SOL, I can't help you. So whenever you get someplace you don't think you belong, like the matrices stuff, press exit until you get back to where you need to be. Okay? Now, we're going to do, we put everything in graph 1, so we're going to hit graph 1, which is F1. Okay? And here is our scatter plot. Now, does that look like a linear equation, line of best fit, or do you think that's maybe a quadratic? What do you think, Jaden? It could be quadratic. It doesn't have that big a curve, though, does it? It looks more like a line. So what we're going to do is we're going to have the calculator tell us which works best. Okay, so I'm going to hit calc, which is F1. And the linear is going to be the X. Okay, so we're going to press F2, and you guys have to hit AX plus B. Do you see AX plus B? That's the one that you want to hit. So with these calculators, sometimes there's a little bit of drawing difference. So did everybody get that? All right, so look at my A is 13.9. My B is 1.27. So my equation is, let me write, yep, all right. My equation is going to be y equals, my A is 13.9, x, and my B is 127.4. So there is my linear equation. If you notice the r and the r squared, the closer those are to 1, the better off, the better fit your line is. So this is not exactly a perfect fit because my r is almost 0.9 and my r squared is 0.8. So it's not necessarily the most perfect line. Okay. But what I'm going to do is I'm going to copy this. So what are we going to hit to copy it? F5. Oh, I got us. We're going to hit F5. and we're going to press enter. You have to press the enter. Okay, and now let's draw it to see if it fits with our data pretty well. So we're going to draw it, and look at that. So there's your line of best fit. Did everybody get that? Okay. So we want to be able to do things with predictions because that's what the line of best fit is all for. Everyone with me? Okay. So what I'm going to do is I can't make predictions here. So I'm going to go to the main menu and I'm going to go to graph. Now when we copied it and we stored it, when we press entered, look at that. It puts it over into the graph menu. So everyone have this in the graph menu? All right, so we want to draw it, so we're going to press F6. And how many of you got this condition error? A lot of you. So what that means is we did not select it. We didn't tell it what to graph. So we're going to press exit. Remember that exit key always takes us back. And notice that when I scroll off from here, it's not highlighted. So having it highlighted, and you want to select, which is F1. Now we're going to ask it to draw. Okay, so we've asked it to draw, and we're going to use that to make some predictions. Our best friend is going to be gsolve. Okay, so we're going to press F5, which is gsolve. Okay, and remember we used gsolve when we were looking at systems. It found us the intersection, remember? So we could find solutions to systems. So here it's got a root, a maximum, a minimum, all kinds of things. But what we want, it's not going to give us a specific point, and we're really going to want a specific point. So we're going to press the more, and it gives us ycalc and xcalc. So if we want to know what the vertical drop is in 30 years, okay, are we looking for an x value or are we looking for a y value? Y value. So what do you think we're going to press? Ycalc. All right, and if we want it in 30 years, we're going to enter 30. When we enter 30, we get this argument error. What that means is that our window that we can see is not big enough. So we're going to press exit again. I'm going to press exit one more time. I'm going to go shift, then view window. So what that view window is the viewing window. So it changes what we see. And notice that your x values, so your domain goes from -1 to 17. Well, if we want 30, is 30 in between -1 and 17? No. All right. So we're going to go and we're going to change that. So we're going to arrow down to the max. And what should we put in if we've got 30? 33 is good, 31, whatever you want to put in. I'm going to put 33 in. I'm going to enter. Okay. And let's make the max y max, so how the domain go up just in case we need to. So let's go with 500 and enter. All right. We're going to go back. How do I go back? Exit. Awesome. So I'm going to go to exit. All right, and then I'm going to draw it again. Everybody here? All right. So now we're going to go gsolve again. So F5. We want the ycalc, so we have to press arrow over, and we want it in 30 years. We're going to press F1, and we're going to enter 30. And this time, we should get that value. So do you see on the bottom, you have an ordered pair of 30 and 546. That means that it's going to be 546 feet. The vertical drop would be predicted to be 30 years after 1988. Everybody get that? All right, so now we have our data in list 1 and list 2. Okay, and we're going to be ready to graph and make some predictions. So now we're going to go ahead and we are going to graph this data. So we need to press the more if you don't have the menu that says graph. And then we're going to hit F1 for graph. So F1. We've already set up our lists from the last problem. So we're going to press graph 1, which is F1. And we're going to get this. Everyone got it? It is a nice curve, yeah. So is it linear, Jack, or is it quadratic? It's a quadratic, absolutely. Okay. So we're going to go ahead and we're going to calculate the line of best fit. So we're going to hit calc. And I don't want you guys to do anything, but I just want to show you something. Okay, so watch what I do. I'm going to go with my linear again, and I'm going to just draw, and I want you to look at the regressions. So you see that you have a regression of 0.76 and you have a regression, the R values of 0.57. So like I said in the last example, that means that it's not a really good fit because it's off. It's not close to 1 or -1. So I don't like that. So I'm going to go back to exit. I'm going to graph it again. Now you guys do this with me. I'm going to do calc. Okay. And quadratics have a degree of 2, right? That's what we've been doing in class. So what do you think we're going to press? F4. So we're going to do x squared F4. And look at your R squared value. Look at this right up here. It's 0.999. Can't get much closer to 1 than that, right? So that means it's a good fit. So we want to save it so we can make predictions, and we're going to press copy. Actually, let's do A, B, and C first. So my A is -15.7. My B is 62.4. And my C is 80. So that means that I've got the equation, and notice on the bottom it tells you exactly where to sub stuff in, right? So I've got A equals -15.7 x squared plus 62.4 x plus 80. So that negative makes sense because my quadratic is going to open down. So I'm going to press copy, enter, and then it takes me back. Was everybody able to copy and enter? Okay. So now I want to draw it. So I'm going to press F6. And there is our parabola. It looks really nice and smooth, right? So it definitely is kind of that equation. All right. So we want to do something with it. So remember, we can't do it in the stat menu. So we need to go to the graph menu. So go back out to hit menu and come back out to where all the menus are and scroll down to your graph. Okay. And it should be saved in there if you did it right. Does everyone have it saved in there? Remember, we need to check to see that it's selected. So no, it's not. It's not highlighted. So cover it up, press select. And now we can draw it by doing F6. So now we need to answer these questions. How long will it take the rocket to reach its highest point? How high will it go? They kind of go together. So remember I said GSolve is your friend. So we're going to go to GSolve. Okay. And how long will it take the rocket to reach the highest point? Well, look at our graph. What do you think we're going to use to find that? Jaden? Max. Okay. The nice thing about pressing max is that gives us the vertex. Okay. So it gives us the vertex of 1.98 or 1.9 and 142. Okay. So it's going to take the rocket 1.9 seconds to reach the highest point, or 2. You notice in our table, okay, there's 2 is our highest point, okay? But mathematically, with this equation, it's 1.9 seconds, really close to 2, because it's 1 point. If we rounded, it would get to 2. And then we round here, it says it's going to go to 142, okay? And even though you have this table, some of the points aren't right on the curve, which is why you see this difference, okay? So now, how long after the launch will the rocket debris hit the ground? What do you think we're going to press to find that? Let's go to G-Solve again. And there are our choices. Where would you think it hits the ground? Not there. It's a parabola. Are there any minimums in a parabola when it opens down? Well, there's no relative minimum on a parabola either. The root. Okay, it's the x-intercept. So our root is 4.99 or 0. So that kind of makes sense, right? Look at our graph. Where is it 0? At 5 seconds. All right. So I've gone over all of these steps to solving it. You have it on its note. Okay. So are there any questions? Remember that G-Solve is our best friend with this graphing calculator.